Have you ever looked at a piece of code and wondered why it behaves in a way that seems completely illogical? If that's you, then you're in the right place. Today, we're diving into a curious case in C++, where a variable is assigned to itself during its definition. I totally get it. It can be confusing when you see code that compiles without errors, yet it feels like something is off. You're not alone in this confusion. Many developers have stumbled upon this peculiar behavior. Here's the specific situation we're looking at. One user recently asked, why is it legal to initialize a variable with itself in C++? They provided an example where an integer is defined as itself, and even a reference variable does the same. Sound familiar? Let's explore this together. So why does this happen? In C++, when you declare a variable, it is created in memory, but its value is not yet defined. This means that the variable can technically reference itself, even if it doesn't make logical sense. Let's break this down further. And don't go anywhere. At the end of this video, I will share a fascinating insight about variable initialization that you won't want to miss. To understand why self-assignment of a variable in its definition is legal in C++, we need to look at how variable initialization works. When the user writes int I equals I, the variable I is being declared and initialized at the same time. In this case, the variable I is not yet initialized when it is being assigned. Therefore, it takes on an indeterminate value. This is why the compiler allows it, even though it may lead to undefined behavior. The user might wonder if there are any practical use cases for this kind of initialization. Generally, there are not, as it can lead to confusion and bugs in the code. It's more of a quirk in the language's design. Additionally, the user should be aware that compilers may issue warnings about such code. For example, using the mass wall flag with G++ can alert the user to potential issues, even if the code compiles successfully. In summary, while self-assignment in variable definitions is legal in C++, it is not recommended due to the risks of undefined behavior and confusion. The user should strive for clearer and safer coding practices. Here's a fun fact. Did you know that the first programming languages were designed for mathematical calculations? It's fascinating how far we've come, yet some quirks still linger in modern languages. Now, let's look at the answers provided by other users. This user explains that the self-assignment of a variable in its definition is legal due to a rule in C++. This rule states that a name is in scope immediately after it is declared. They argue that complicating this rule to prevent such assignments would be unnecessary. Now, let's shift our focus to a different response. This user points out that just because the compiler accepts the code, it doesn't mean it behaves correctly. They explain that the compiler isn't required to catch all instances of undefined behavior. It's up to the programmer to ensure their code follows the language rules. For example, initializing a variable with itself, like int I equals I, is syntactically valid, but doesn't make logical sense. The compiler may not warn you, and it can produce unpredictable results because you've invoked undefined behavior. That's it for that response. Let's explore another one. This user explains that the self-assignment in C++ is legal due to the language's scope rules. When you declare a variable, like in int I equals I, the second I refers to the same object as the first, but it has an indeterminate value. This behavior is defined in the C++ standard, which states that the point of declaration is right after the variable's declarator and before its initializer. The user also notes that while compilers like G++ and Clang may issue warnings for such cases, the rationale behind this scope rule likely stems from C, where it was originally established. Changing it now could lead to confusion, especially if the second identifier were to reference an outer scope variable. Here's the insight I promised. Understanding how variable initialization works can save you from a lot of headaches in programming. Always remember to initialize your variables to avoid confusion and bugs. And there you have it. You've learned why self-assignment and variable initialization is legal in C++, but also why it's not a good practice. If you found this video helpful, hit the subscribe button for more programming tips and keep coding with confidence.